Remote Sensing by Manas Shah. Remote sensing is the way in which satellites use tools to collect data about the Earth. For example, a satellite called Jason-2 is creating an ocean topography map that shows the features of the ocean as you watch this video. Jason-2 is part of the Jason series, a combination of effort between NASA and CNES, the space agency from France. The Jason series focuses on ocean topography and some land topography following 2015. The satellite itself uses coarse sun sensors on its solar array for power, a full aperture calibrator to calibrate its altimeter and other tools, as well as an instrument aperture for the instruments themselves. LIDAR, or light detection and ranging, is the process of taking pictures of the ground from a high altitude to take a three-dimensional topography map. These topography maps are used for things like GPS reference. Here is an image that was created using LIDAR data. This image shows Manhattan, and as you can see, each color represents a different height and also terrain. The lowest part of the terrain is green, and the highest part is purple. Laser altimeters also use the data collected from LIDAR missions. They take the topography from the most recent LIDAR and use it to do what normal altimeters do: find the height above the ground that the satellite is at. In order to do a LIDAR mission correctly, the satellite/plane/helicopter needs more than laser altimeters. For example, satellites use tools called altimeters, not to be mixed with laser altimeters, to measure the height from the ground and in between in order to create data about the satellite's height. Jason-2 also collects data about things like El Niño and La Niña. Jason-2 also collects data about things like El Niño and La Niña. Jason-2 first creates NASA and CNES then send the photos to weather forecasting corporations all around the world. The corporations use this data to predict when storms are coming and how hot or cold it will be the next day. Someday, the weather corporations will be completely responsible for the data collected from remote sensing. Having constant access to the mounds of information coming from satellites like Jason-2 would definitely be an advantage on the weather. The satellites have now been decommissioned, but were part of the beginning of remote sensing, as shown in this picture. Along the ocean topography series comes Topex/Poseidon, which had an accuracy of 4.2 centimeters. Then comes Jason-1, which had an accuracy of 3.3 centimeters. Finally, there's Jason-2, coming in with an amazing accuracy of 2.5 centimeters, and Jason-3 predicted to be launched in 2015. However, the accuracy itself is only the difference between the actual sea level and the measurement taken by Jason-2, Topex/Poseidon, or Jason-1. One tool that satellites used is a radiometer. Radiometers measure the intensity of electromagnetic radiation near the satellite. By measuring reflected pulses of electromagnetic radiation, radiometers can really help create a picture like this one to show how high the wavelength is when things like ocean topographies are created. Another tool the satellites use is an imaging radiometer. An imaging radiometer is a radiometer that instead makes a picture based on the data that is collected using pixels. Pixels are small squares that are certain colors to be put together into bigger pictures. For example, the screen you're looking at right now is made up of thousands of pixels. Radar, or radio detection and ranging, measures the time of arrival of backscattered or reflected pulses of radiation to show where something that cannot be seen normally is. Now, onto the history of remote sensing. On April 1st, 1960, NASA launched TIROS-1, a television and infrared observation satellite, proving that satellites really can monitor Earth's weather patterns by measuring infrared lasers to create images. In 1972, NASA launched Landsat, the first satellite in a series that today ends up with Landsat 7. The Landsat series, over time, took topographies of the land in a similar way that Jason 2 or Jason 1 took topographies of the ocean, like the picture that's on screen now. Later, in the spring of 1992, NASA launched the first atmospheric laboratory for applications in science, or ATLAS, on the Space Shuttle Atlantis for the purpose of studying the chemistry of Earth's upper atmosphere and the sun's energy, and it carried 14 total experiments. Finally, in 1999, NASA launched Terra, the flagship satellite of the Earth Observing System, EOS, which is a series of spacecraft that represents the next landmark steps in NASA's mission for remote sensing. As a recap, you learned that remote sensing is how satellites monitor Earth's surface, and that it started in 1960. You also learned that satellites specifically create topographies to show the data they've collected in their remote sensing. You even learned about the tools they used, like altimeters and radiometers.